What's going on, guys? Mr. Gill back in the house. Hope you guys are doing okay. That's good. Hope you had a nice Thanksgiving like I did. I didn't even eat any turkey. I did some shrimp and some crab legs and some corn on the cob. That's right, it wasn't traditional. But I hope you had a nice time with your families and eating turkey and doing all your math work. So guess what now? Tis the season to be given. And I'm gonna give you a chance to get your work done that you have not been doing. That's right, I'm in the spirit of giving. Now, don't make me give a 0. Make up your work. You can turn it in late, I guess. If you don't, it's gonna be a 0. Can't affect your grade, as you know. So I'm giving you the opportunity to make up your work this week because you're going to be out of school pretty soon. And it's going to, the report cards are going to come out. And what you going to say to your parents during Christmas? Mommy, I made all F's. No. You want to make your parents proud. Got it? Okay, here we go. Let's start with today's lesson. Today's lesson dealing with probability, dependent events, independent events, probability of a compound event, and number of outcomes. November 30th, 2020. Make sure you're taking notes because you're going to have some IXLs to do, and you're probably going to have one already assignment to do. You guys ready? Let's do it. A dependent event is this. 2 events are dependent if the outcome of the first event does affect the outcome of the second event. So you're dependent on one another. It does affect. There we go. Does affect the outcome of the second event. They are dependent. Make sure you know it. Independent. 2 events are independent if the outcome of the first event does not affect the outcome of the second event. And so, I'm independent. I don't need anybody. I'm independent. There we go. That's right. You see the difference? Dependent? Okay, I'm dependent on that person. Or independent. I don't need anybody. You got it? There we go. That's the difference between dependent and independent. Independent, again, does not affect the outcome of the second event. Now we're going to do some problems. You guys ready? It's going to be either independent or dependent. You guys ready? Let's do it. Here we go. First one. Tony picks a card at random without putting the first card back. She then picks a second card at random. She picks a card at random without putting the first card back. She didn't put the first card back. Then she picks a second card at random. Dependent or independent? You are going to have to go with dependent. That's right, dependent, because she drew a card and she didn't put the first one, she didn't put it back without putting the first card back. She laid it around. So that's dependent on, because she did not put the first card back. You got to go with dependent on that particular case. Any questions about that? Had she put the first card back, it'd have been nothing to depend on. It'd have been independent again. Everybody, yeah, let's do another one. Cora spins the spinner twice. Are those 2 events dependent or independent? She spins the spinner twice. She spins the first time, 1 out of 4, and then she spins the second time, 1 out of 4. Dependent or independent? Here we go. Very simple. This one is going to be independent. Both times. The first time she spun it, that was independent. The second time she spun it, that was independent. So you got to go with independent. Everybody catching on how this is going. Let's do another one. A customer selects a brand of orange juice to buy for her family at the market. In a different market, another customer happens to pick the same brand of orange juice. Is that dependent or independent? She picks a brand for her family at the market. And it says in a different market, another customer happens to pick the same brand of orange juice. Dependent or independent. You know it's easy. She didn't have anybody to depend on when she's picking that in that market. And then another customer in a different market, he picks the same brand. So both of them are independent. They're not dependent on one another. You know why it's independent? Because it was two separate markets. You understand what's going on there? You're getting the gist of this. That's what I thought. Let's do another one. Jane purchased a new car from a dealership in Rockport. An hour later, another customer buys a car from the same dealership. Independent or dependent? If you really don't get it, try reading it again. Shane purchases a new car from a dealership in Rockport. An hour later, another customer buys a car from that same dealership. So he buys a car at the dealership, and then that same customer buys a car. That's going to be dependent because Shane bought a car there, and that guy might want what Shane bought. And he won't be able to get it because Shane bought it. So guess what that answer is? It's going to be dependent. That's right. You get it. Dependent. Because they bought the cars from the same dealership. You might have wanted that car, but no, Shane bought that car. So hope this is giving you a better definition of dependent and independent used in probability. Now, we're going to talk about two more things. It's going to be kind of simple. Outcomes and probability. Outcomes and probability both are different. So here we go. Let's see here. You got two six-sided dice. What are the outcomes? 6 sides there. What are the outcomes? Outcomes is different from probability. Outcomes is very simple. You got two six-sided dice. Okay, 6, right? So instead of adding 6 plus 6, you're going to multiply them. That will be the outcomes. That's right. So 6 right here. You got 6 right here. Okay, well, you got 6 right there. You got 6 right there. 6 times 6. 36. That's the outcomes. And not 1 over 36. We're talking about outcomes. We're not talking about probability. Now, when we talk about probability, what's the probability of drawing a 5? Or what's the probability of drawing a 1? Or what's the probability of drawing a 4? That will be, since you got 2 of them, because this is multiple, I'll say the probability of that will be 1/6 times 1/6, which is 1 over 36. If you want, they might ask you for a percent. If they ask you per percent, you just do 1 divided by 36, and you get that right there. So probability is different from outcomes. Outcomes, you just do, you got 6 right here, and you got 6 right here, and you got 6 right here. You just do 6 times 6. Don't do 6 plus 6. You do 6 times 6. 36 for the outcome. Now, if they ask you for probability, you do 1 out of 6 times, not plus. 1 out of 6 times 1 out of 6 would be 1 over 36. They might ask for a fraction. If they ask you to turn in that percent, that'll be 2.7%. You just do 1 divided by whatever the number is. And most of y'all, you guys use a calculator anyway, or you use a cell phone, or you use Google. Ain't nobody using their minds these days. Let's do another one. Does everybody see the difference between outcomes and probability? Outcomes, you just do, you count the number of sides. You got 6 right here, 6 right here, 6 times 6, 36 right here. Probability, 1/6 times 1/6 equals 1 over 36. Two different things. Let's do another one. What's the outcome these two spinners. It's called these are called compound events. You know what's compound? Two or more. Sometimes it could be three or more. Compound events, two or more. So right here, class, we have 4 right here. And how many do we have right here? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 right here. 8 times 4. How hard is that? That's your outcome. That's all it is to it, man. I'm not lying. Yeah, that's all it is to it. 4 times your outcome equals 32. What's the probability? The probability is a little bit different. This first spinner, you have 1/4. The second spinner, you have 1/8. Equals 1 over 32. Everybody got it. And then, if you want to change that to a percent, you know what to do. You just do 1 divided by 32, and that will give you a percent. Everybody got it. Probability and outcomes, 2 different things, but they're kind of simple. The outcomes, you just count the number right here. So you got a total of 4 right there. Count what you have right there. What you have here is 4. What you have right here, number of spaces you have, you got 8. Multiply them both together, 32. Probability, that'll be 1 out of 4. This will be 1 out of 8. You multiply both of them together. You should already know how to multiply fractions. Everybody got it. Sometimes they might ask you for a fraction, 1 out of 32. And sometimes they might ask you for percent. And then you can always, what y'all always do, you always use Google, or you pick up your cell phone and say something like this. Google, what is 1 divided by 32? And then Google says, oh, I don't know. Google, what is 1 divided by 32?
The answer is approximately 0.03125.
There we go. So we're talking about 3.1%. That's right. Yeah, Google is awesome, isn't it? That's what I thought. Everybody got it. So, outcomes, count the number of spaces, 4. Count the number of spaces, 8. 8 times 4, 32. Our Excel will explain it to you. If you don't get it, refer back to the videos. Again, you will have 3 assignments to do in Excel. You're going to have 1 assignment to do in Reiki, and you're going to have a little bit of assignments to do in your workbook for the week. And on Tuesday, you'll be taking the already test again. That's right. The already test will begin on Tuesday again. I think if you make high growth, you're going to get something, but that's not up to me. Any questions, comments? You got a question out there? Okay, that's what I thought. All right, guys. I'm just glad you guys had a nice Thanksgiving. And as usual, you know the deal. We always like to do? We always like to do artwork. So here we go again. Back to the artwork. There we go. This. This Just beautiful, beautiful, beautiful artwork. Covering some of your spots. Some of them pretty big. And then let's love one another. How's that sound, guys? Okay. Until next time, I'll see you guys in virtual land. Mr. Gill is going to sign.